Hello students, this is Professor Chalai, and in this video we're going to look at solutions and molarity. By the end of this video, you should be able to calculate the concentrations of solutions in molarity and also relate the concentrations to other properties such as the number of moles or the volume of solution. As always, you can follow along with our chapter workbooks. Now, before we can begin, let's look at a formal definition of solution. A solution is simply a homogeneous mixture. Remember what our definition of homogeneous mixture is, of two or more substances. Typically, when we think of solutions, we think of solutions in the liquid phase, like things dissolve in water, but that's not the only definition of a solution. You could have solutions that are mixtures of solids and liquids, liquids and liquids, gases and gases, gases and liquids, and even solids and solids. For example, alloys of metals or mixtures of two different kinds of metals, it's a solid solution. Others might disagree with me on that point, that solids are in fact homogeneous mixtures, but it depends on the alloy. Okay, there are two components to a solution. The first we'll call the solute, which is the minor component of a solution. And the second component we'll call the solvent, which is the major component of a solution. So solute is the minor component of a solution, solvent is a major component of a solution. And for most of the solutions that we'll be looking at in this course, we'll be looking at what we call aqueous solutions. So this is a solution where the solvent is water. They're the most common types of solutions, and so they're what we'll be looking at mostly throughout this chapter. Aqueous solutions where just the solvent is water. And so what we'll be interested in are what the solutes are and what the solutes are doing. So let's look at an example of such an aqueous solution. I gave this example already in one of my previous videos, but I'll do so again. So let's say you had a cup of water and a bucket of water, and within both of these you dissolve, let's say, a spoonful of salt, right? So you dissolve it and it dissolves into the liquid. If you were to taste these, they would taste differently because their concentrations of salt solution would be different. For example, this one, the cup of water, will be saltier even though you put the same amount of salt into the bucket of water. And so the fact that they taste differently comes from the fact that their concentrations are different. And so a concentration is simply a measure of the amount of solute in a solution. So in this case, there were more solute per amount of solution in the cup of water than the bucket of water. Or we might say that the concentration of salt in the first solution was higher than the concentration of salt in the second solution. So there are two things here to determine the concentration: the amount of salt that we started with and the amount of water that we dissolved it in. So as you would guess, the concentration can be calculated using the amount of solute and the amount of total solution that we end up having. The amount of solute we typically measure in number of moles, whereas the volume, the total amount of solution that we have, is usually measured in liters. And so this unit, moles divided by liter, we'll call the molarity, or big M. And so that's what the molarity is. The molarity is just a measure of the concentration where we divide the number of moles of the solute by the number of liters of total solution that we have. There are going to be other units of concentrations that we're going to use, but for now let's stick to molarity and let's look at some of those calculations. So now that you know how to calculate molarities, try to see if you could do numbers 27 and 28 by yourself. Pause the video, and when we unpause, we're going to look at them. Okay, so number 27, it says that we have a solution with 25.5 grams of KBr in water to have 1.75 liters of solution. What is the concentration in molarity? Well, we know that the molarity should be equal to moles of solute, in this case the solute is KBr, divided by volume of solution, SOLN for solution. So let's see if we can try to figure these things out. We don't have the moles of KBr, but we have the mass of KBr. Can we figure out the moles? Well, yes, if we know the molar mass of KBr. So let's calculate that. The molar mass of KBr is equal to the molar mass of K, which is 39.10 grams per mole, plus the molar mass of Br, which is 79.90 grams per mole. You add those up, and we get 119.00 grams per mole. There's only one K and one Br, so that's the molar mass of KBr. So if we want the number of moles of KBr, we take the mass, 25.5 grams, divided by the molar mass, 119.00 grams per mole. The grams cancel out, and for number of moles of KBr, we get 0.214 moles. So to calculate the concentration in molarity, we get 0.214 moles divided by the volume, 1.75 liters, 1.75 liters, and we get 0.122 moles over liter, but moles over liter is the same thing as molarity, so that is our answer. If you didn't get that answer, let me know and we can go over it together. But molarity is moles over liter of solution. We needed the moles. We used the mass and the molar mass to get moles, which is a type of calculation that we've seen many times now. And then we just divide that by the liter to get molarity. Number 28, if you haven't done this yet, pause the video and try to work it out by yourself. But in number 28, we have the molarity and we have the number of moles. So molarity is of the solution. In this case, it's NaOH. We know it, it's 0.125. So this should be the number of moles of NaOH, which we also have, 0.255 moles of NaOH. And what they're asking us to find is how many liters of solution do we have. So what we need to find is liters of solution. Well, we just need to rewrite this problem to solve for liters of solution. So if we multiply liters of solution on both sides, right? Let's get rid of that so we can multiply liters of solution. And then we divide by the number of moles of NaOH on both sides. There we go. Then we can solve for liters of solution. So let me just rewrite this easier. So liters of solution, there we go, is equal to 0.255 moles of NaOH divided by 0.125 moles of NaOH. And in these calculations, molarity is just moles over liter. So moles will cancel out and we're left with liters in our answer, which is what makes sense. 0.255 divided by 0.125 gives us 1.80 liters to 3 sig figs. And so that is our answer. Again, once we know the formula for molarity, which is moles over liters, we can figure, if we have any two of these, we can figure out the third by just using a little bit of algebra and rewriting the equation. All right, in our next video, we're going to look at how we calculate dilutions of solutions. I'll see you then. Bye.